Okay, we're good now. Let me take a break though.
Are you sure about that?
Mission failed. We'll get them next time.
What's up, everyone? Today I'm gonna take you behind the scenes of one of my favorite projects, building a 6-axis robot arm from scratch. Yes, it moves, it grabs, and yes, it almost grabbed a knife when I left it alone. But jokes aside, let's start from the beginning, the CAD modeling. The modeling part of this project took the most amount of time because I decided to start from zero when it comes to the gear train. I could have used the already available planetary gearboxes that get mounted in the NEMA 17, but I chose instead to use double helical gears for the gear train. First of all, because they are a little bit quiet, cheap, and also they are more precise. For the body of the robot, I choose to use 8 mm thick sheets of acrylic. This type of acrylic is recycled from the backlights of all the TVs. Since you can notice there is dots on it for dispersing light. For the joints, I use flange bearings, 8 mm flange bearings. They are very cheap and available, and 8 mm threaded rod. They'll be stuck. God damn. God damn. For the belt, I just use the GT2 with the steel core inside it, so I can reattach the ends and make my own custom closed loop GT2 belts because I couldn't find the length online. The belt is very strong since I'm not using the whole length, so I'm not gonna reach the point where I attach the both ends, where I solder them both, so it's strong enough. Alright, let me show you the very first version of this robot arm. At this point, I just want to prove the concept, make a move, record a couple of positions, and repeat them. So for the controller, I actually use the basic AR remote, the kind usually meant for controlling RGB LED strips. Nothing fancy, but it worked. I mapped each button to a specific motor direction or function. I set it up so I could manually move the arm with the remote. For example, this button would rotate the base, this one would move join 1, and so on. Then I added two specific buttons on record position 1 and another for position 2, and another two buttons for cylinder speed 1 and speed 2. After recording both positions, I had a third button, the play button, which told the robot to start moving back and forth between those two positions, and it would just keep looping the movement until I press the stop button. So, after getting the first version of the robot working, I started running into a lot of problems. First, the NEMA 17 stepper I used for joint 2 started heating up like crazy. At first I just thought maybe it was a driver setting or micro stepping, but no. It turns out it was just underpowered for the job. That joint had too much load, so I swapped it out for a NEMA 21, and immediately it ran cooler and smoother. Then there was the gripper. I originally used an SG90S servo, thinking it would be enough to grab a light object, but no. They just kept burning out. The torque wasn't there, and they overheated while just trying to hold stuff. I literally went like four of them. So I ended up redesigning the whole gripper, reinforcing the structure, made it stronger, and replaced the SG90S with a more powerful metal gear servo that could actually handle the holding force without melting. And on the software side, I hit another wall. My own code only supported two position recordings, and that was not enough for what I wanted. So I just started exploring better control options, and eventually I discovered the Anin robotic software. It was a total game changer, much more advanced, smoother playbacks, and real-time control.
I'll live each second like my final day. You can't take that away.
Alright, that's it for this video. I hope you enjoyed watching. If you found this interesting or helpful, feel free to drop a like. And if you want to see more DIY projects like this one, consider subscribing. It really helps me stay motivated and keep sharing these builds with you guys. Thank you for watching, and I see you to the next one. Perfect.